Hello everyone, in this video we'll study about hydrogen, the first element in the periodic table which has atomic number 1. It has properties similar to that of alkali metals and halogens. Hydrogen was discovered by Henry Cavendish and is prepared by displacement reaction of metals. In laboratory, hydrogen is prepared by the action of dilute sulfuric acid or dilute hydrochloric acid on zinc. In this video, we'll study all this in detail. As we see here now, the atomic number of hydrogen is 1. The symbol is capital H. It has valency 1. Atomic mass is 1. Molecular formula of hydrogen is written as H2. It is a diatomic gas. Electronic configuration is again 1 with 1 electronic shell as it has only 1 electron and 1 proton. Relative molecular mass of hydrogen is 2 and position in the periodic table is first period and first group. Coming to the discovery of hydrogen, in 1671, Robert Boyle discovered and described the reaction between iron fillings and dilute acids, which results in the production of hydrogen gas. In 1766, Henry Cavendish was the first to recognize hydrogen gas as a discrete substance by naming the gas from metal-acid reaction as flammable air. Occurrence of hydrogen. Hydrogen exists in both free state as well as in combined state. In free state, it is found in traces of Earth's crust and atmosphere. Combined state, it is present in the plant and animal tissues, which are made up of compounds of hydrogen with carbon, oxygen, and nitrogen. Hydrogen is present in acids, alkalis, hydrocarbons, proteins, etc. In water, it is 11.1% by weight. Let us now see different methods of preparation of hydrogen. That is, preparation of hydrogen by the action of metals with water, acids and alkalis. If we see here sodium and potassium, which are highly reactive metals, they react very violently with cold water. The reaction is exothermic and the hydrogen which is released catches fire immediately. If we look at the reaction, potassium combines with water, displaces hydrogen from water, forming corresponding alkali, that is potassium hydroxide, liberating hydrogen, and a large amount of energy is evolved or heat is evolved. If we talk about the reaction with acids, it again reacts violently with acid with rapid effervescence and splashing. Sodium combines with HCl, forms sodium chloride and liberates hydrogen. Calcium reacts less violently with water. Heat evolved in the reaction is not enough for the hydrogen to catch fire. And calcium on reaction with water forms calcium hydroxide, which gives slight turbidity, liberating hydrogen. It again reacts with the acids like H2SO4 or HCl, forming the corresponding salt, liberating hydrogen. Magnesium is the only metal which reacts with hot water and forms magnesium hydroxide, liberating hydrogen, but the reaction stops after some time. Magnesium also combines with steam to form magnesium oxide, liberating hydrogen. Magnesium readily reacts with acids to form salt, liberating hydrogen. Aluminium, zinc and iron, they react with steam to form oxide and hydrogen. Aluminium combines with steam, forms aluminium oxide and hydrogen. Iron also combines with steam, forming iron oxide and hydrogen, but in the case of iron, the reaction is reversible. Elements aluminium, zinc, iron can also displace hydrogen from the acids. Hydrogen is also prepared by the action of some metals with alkalis like aluminium, zinc and lead can combine with alkalis like sodium hydroxide or potassium hydroxide, forming corresponding salt and liberating hydrogen. If we see here, zinc combines with sodium hydroxide, forms sodium zincate, liberating hydrogen. Talking about the laboratory preparation of hydrogen, for this The reactants used are granulated zinc, dilute sulfuric acid, or dilute hydrochloric acid. Reaction involved is zinc combines with dilute H2SO4, forms zinc sulfate and hydrogen. Zinc combines with dilute hydrochloric acid, forms zinc chloride and hydrogen. Now, zinc granules are usually preferred for the reaction rather than pure zinc because the impurity present in granulated zinc is copper, which acts as a catalyst and speeds up the rate of reaction. The setup which is used here is a round bottom flask where we take zinc granules. To this round bottom flask, there is the dropping funnel or the thistle funnel attached and a beehive shell. So when the acid is being added to the zinc granules, the reaction starts with effervescence and the hydrogen which is produced is collected by downward displacement of water since it is insoluble in water, and we can see those bubbles of hydrogen rising up. Hydrogen is not collected by downward displacement of air since it forms explosive mixture with air. There are different impurities present in hydrogen which is prepared in the labs, and because of that, hydrogen has faint fishy odor. Pure hydrogen is odorless. So in order to remove all these impurities, the gaseous mixture of hydrogen and impurities is then passed through various chemical reagents to remove these impurities stepwise. For example, hydrogen sulfide is removed by passing the gaseous mixture through lead nitrate solution. Oxides of sulfur, nitrogen, carbon dioxide are removed by treating it with potassium hydroxide. Phosphine and arsine are removed by treating it with silver nitrate solution. And water vapor or moisture is removed by passing the gas through anhydrous calcium chloride, which acts as a dehydrating agent. So we get pure dry hydrogen. This is how we prepare hydrogen in laboratory. Thank you.